Okay, so for practice here, I'm going to record and show you how to do number 18. I feel like 16 and 17 will be easier, so the most difficult will be 18. Let's tackle that together. All right, if the point -7, -5 is on the terminal side of theta, our angle, we go ahead and we draw a graph, and we put the point -7, -5, and we can estimate it a little bit. We don't have to be exact, but let's say this is the point -7, -5. Now what that means is, if it's on the terminal side of an angle, it means that, okay, well, the angle might have started there and gotten bigger, 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 past 90, now it's passing 180, and now all the way down there, our angle is the angle between the positive x-axis here all the way around to there. Okay, so now we've got that angle there, and this angle is angle theta. But remember, trigonometry is all about right triangles. So far, we don't have a right triangle, and theta is so big, I can't fit it inside of a right triangle. So what we do is we make a right triangle with the closest part of the x-axis. So the closest part of the x-axis is right about here. I draw a line from that point to the x-axis, and there is my right angle. Therefore, I now have my right triangle. Now I know a couple of things about this right triangle. I know that this value right here is equal to -5, because that was the y-coordinate of the point, and that measures how far below the x-axis we are. I know that the value here is -7, and again, that's because my x-coordinate this time is -7, which that measures how far away from the y-axis I am. So I have measurements for x and y. Now all I need to finish off my right triangle is this side right here. In any right triangle, if you have two sides but are missing the hypotenuse, all you have to do is the Pythagorean theorem. So this time I have A and B. I just need C. Remember, C is the hypotenuse. So we'll call A -7. I'm going to square it. And B would be -5. To square that, that equals C squared. So 49 plus 25 equals C squared. Now I take and add them up, and I believe I get 74 equals C squared. And to finish that, I take the square root of both sides, and I find out that C equals the square root of 74. So I replace my question mark here with the square root of 74. Now, if you can simplify that at all, you should, meaning if it has a perfect square factor. I know 4 doesn't go into it, and I don't know if anything else does, so I'm going to go ahead and leave it as just the square root of 74. Okay, so we know everything we need to know about our triangle. The one thing we have to be careful of is, again, theta was too big to put in a right triangle. Theta here was too big to put in a right triangle. But everything about this angle here is the same as everything about theta. So we simply focus on this angle here, this blue one I've just drawn. You can give it a name if you want to. You can call it, I don't know, alpha. Kind of looks like a little fish if you want to, but everything about alpha is the same as everything about theta, except some positives and negatives will be different. So let's start here first with the sine of theta. Okay, we go up to our triangle that we made, and we think about theta as very similar to alpha here, and the sine we know is opposite over hypotenuse. Which side is opposite of alpha? -5 is opposite. And the hypotenuse is the square root of 74. Obviously, this is not in simplest radical form, so I have to finish off by doing square root of 74 over square root of 74. That multiplies out, and I get the sine of theta is -5 times the square root of 74 all over 74. Now let's go with cosine of theta. Well, instead of theta, we're going to be looking at alpha here. And so the adjacent side to alpha is -7. The hypotenuse is still square root of 74. So I multiply by radical 74 over radical 74, and I get -7 radical 74 over 74. 2 down, 4 to go. Tangent will be a lot easier here. Tangent is opposite over adjacent. Well, again, we're talking about theta is the big angle, but we're looking at alpha because that's the one that fits in the right triangle. And the opposite side is -5. The adjacent is -7. Negative divided by a negative reduces to positive over a positive. So tangent equals 5/7. Now for our reciprocal functions. The reciprocal of sine, we know, is cosecant of theta. Well, all it means is I need to flip over sine, right? But don't flip over this one, because if you flip over this one, it puts the square root back on the bottom. Instead of flipping over that one, flip over this one, the first one we got. Because if you flip that one over, you get square root of 74 over -5. And then you're done. You don't have to worry about simplifying the bottom anymore. Same thing with secant of theta. Don't go to this one. Instead, go back to this one. Flip it over, you've got square root of 74 over -7. And finish off by doing cotangent of theta, and you get 7/5. So there are all 6 trig functions of the angle theta up there that got us into the third quadrant. And now practice on the other 2.